Hi guys, I am Muchekwa Ellen Dangeni with Maths XYZ, and today I'll be introducing you to a new chapter, which is geometry. So we'll just do a bit of introduction into the chapter so that we will understand more when we continue on lessons on geometry. So in geometry we have this six shapes here. I will introduce you to six shapes that you must always consider when you are answering questions in geometry, and that will help you to understand more complex questions regarding this chapter. So the first one here, which is you can see that we have the angle of x and also the angle of y. So these two angles, when they are together, they are actually called the adjacent angles, and they are on a straight line, which is this line here. So this angle and this angle, they are adjacent to each other. So according to geometry, when two angles are adjacent to each other and they are on a straight line, they are actually called the supplementary angle. Supplementary angle, that means that when we add the two angles, they must give us a sum of 180. So with this first one here, you must know that x plus y, which is this angle plus that angle, when we add them, they must give us 180 degrees because they are supplementary angles. So that is the first rule that you must know in geometry, that adjacent angles on a straight line, they are supplementary and they add up to 180 degrees. Alright, so moving on to the second one, which is this one here. We have two angles which are x and they are equal to each other, and we have also those two angles which is y and they are equal to each other. So the x and x, they are actually vertical opposite to each other, and also the same with the y. Their angle of y, they are vertically opposite to each other. So according to geometry, that means that vertical opposite angles, they are always equals to each other. So that's why we know that from this angle of y is equals to the angle of y, and the angle of x is equals to the angle of x. And also something that you must consider is that this is a point. So when we add those four angles here, which is x plus y plus x plus y again, they must actually give us a sum of 360 degrees because they are around the point. So that you will understand more when we continue to the next one, which is number 3. With number 3, we have an angle of r, s, t, and u. So with this angle is the same thing as this one, that when you add angles around a point, they must always give you a sum of 360. So the same with this one, that you will understand more, that when we add those, they must give us 360. So with this one here, we know that the angle of r plus the angle of s plus the angle of t plus the angle of u, they must give us 360 degrees, which is revolution. So the same with this one here, we can actually say that angle of x plus the angle of x plus the angle of y plus the angle of y should give us 360, which is revolution. So we can always start this is x1 plus, or this is x2, but anyway they are equals to each other. Alright, then moving on to the fourth one, which from the fourth one you can see that we have two arrows pointing that side. This arrows only shows you that those two lines, they're parallel to each other. So that means that this line here and this line here, they are moving in a parallel direction to each other. So with parallel lines with lines being parallel to each other, that means that those two angles here, they are actually equal to each other. They are called the corresponding angles, those two. So the corresponding angles of a parallel lines, they are always equal to each other. That means that x here is equals to x. So this angle there is equals to that angle there. Alright, and then when we move to this one, which is number 5, you can see that it forms a Z like this. So this angle is there and the other one is here. That's the first angle which is there, and the other angle is here. It forms a Z shape here. So with these two lines, as you can see, I told you that wherever you see the arrows, that tells you that the lines are parallel to each other. So the first line and the second line, they are actually parallel to each other. So these two angles here, they are actually called the alternative angles. So with alternative angles of a parallel lines, they must be always equals to each other. That means that this x and that x, they are actually equals to each other. They are called alternative angles. And then moving on to the sixth one, which is this one. again we see that those two lines, they are parallel to each other. As you can see that number 4, 5 and 6, we are dealing with parallel lines. These two are parallel, those two are parallel, and also those two lines are parallel to each other. So with this one, with the sixth one, as you can see that this angle here, it's not equals to that angle there. So what happens with these two angles is that they are co-integral angles. So the co-integral angles of parallel lines, they are always supplementary angles. That means that when you add those two angles, they must give you a sum of 180. So the angle of x plus the angle of z is equals to 180 degrees, which is also the same as this one. As you can see that this and that and this shape, they give us supplementary angles which sum up to 180 degrees. And then another thing about this two is that angles around a point, they must always add up to revolution, which is 360 degrees. All right, moving on to other shapes on this. Sorry guys, I'm just wanna tilt the board. All right, moving on more into triangles. With the first triangle here, which is this one, we can see that whenever you see this sign, then you must know that your triangle is a right angle triangle. That means that this shape here, this angle right here, is equal to 90 degrees. So whenever you see this shape, you must know that this only tells you that the angle there is equal to 90 degrees. And also you must know that when you are dealing with a right angle triangle, you are actually allowed to use the theorem of Pythagoras, which with the theorem of Pythagoras, we know that the longer side is hypotenuse, which is normally denoted with the sign of r, and also this side, which is here, is adjacent to this angle, and this one is opposite to the angle. So what happens here is that with the theorem of Pythagoras, we have r squared is equals to x squared plus y squared. Thus, when you are looking for this side, you must always use this equation that r squared is equals to x squared plus y squared, and also this 2. So you must know that only with the right angle triangle, that's where you are allowed to use the theorem of Pythagoras. With other triangles that are not right angle, the theorem of Pythagoras cannot apply there. It only applies where there is 90 degrees angle within inside the triangle, which is this one. All right, and then moving to the next shape, which is the shape of triangle. Again, we see that whenever you see these lines, if it's just one line along the side, then you must know that the two are equal. For example, this two, it only tells us that they are equal, and here it only tells us that these three sides, all of them, they are equal to each other. So this kind of triangle is called the equilateral triangle, of which with equilateral triangle we see that all sides are equal. So that is the first property of equilateral triangle, that all the sides within the triangle, they are equal to each other. And also, if the side of the triangle, they are equal to each other, that only tells you that the opposite angles of those sides, they are also equal to each other. That means that this angle and this angle and that angle, they are also equal to each other. And also mind you that angles of a triangle, they must add up to 180 degrees. So if all angles are equal within the triangle, and we know that the sum of angles inside the triangle, they must add up to 180 degrees, then we can just say 180 degrees divided by 3. That will give us the value of the angle within inside the triangle. So 180 divided by 3, it will always give us a 60 degree. So we know that with equilateral triangle, that means that it won't change. It will always be 60 degrees angles inside the triangle. Okay, and then moving on to the next triangle, which is this one. With this triangle, we see that these two sides are equal. So when the two sides are equal, it only tells us that the opposite angles of those sides, they are also equal to each other. So this angle is opposite to that one, and this angle is opposite to this one. So this tells us that these two angles as well, they are also equal to each other, since these two sides are equal to each other. So the only difference will be this angle. It won't be equal to this two, and also this side, it won't be equal to those two sides. So those are the properties of this triangle, which is only two sides are equal. All right, and then moving on to the 10th shape, which is this one. In this triangle, we see that the three sides are not equal to each other. So you can see this one is donated by just one one line, and this two, and also that one is 3 lines. And you can see that inside the triangle we have an angle which has a sign of just a dot, and this one is one curve, and this one has 2 curves. So with this kind of triangle, all sides are not equal, and that tells us that also the angle inside the triangle, they are not equals to each other. So with this kind of triangle, what we need to know is that this side is opposite to this angle is opposite to this side, and this angle is opposite to this side, and this angle is opposite to the other side of it. So this angle is called the scalene triangle because the side, all sides are not equal, and also the angles are not equal. So this one is a scalene triangle, and this one, I don't think I told you guys that this triangle here is called an isosceles triangle. So this one is an isosceles triangle, of which we know that the 2 sides are equal, and also the 2 angles are equal. All right, and then moving on to the 11th one, which is this one here. So with this triangle, just to make it clear of the point that I've already told you about, guys, that when you are dealing with triangles, all 3 sides, all 3 angles in the triangle, when you add them, they must always give you a sum of 180 degrees. So that means that here it's angle of x plus the angle of y plus the angle of z. They must always give you a sum of 180 degrees. So the angles of a triangle is equals to 180 degrees. Then moving on to the 12th shape, which is this one, we have an angle of x, y, z, and z is outside the triangle. So this z here, it says that according to geometry, that the angle of z, which is there, it's equals to the sum of x and plus the sum is equals to the sum of x and y. So this one, it says that the external angle of a triangle is equals to the sum of 2 opposite angles inside the triangle, which is this one. So this one here is an external angle because it's outside the triangle, and these two, they are opposite to this angle, and when we add them together, they must always give us the value of the external angle, which is z there. All right, and then if you can check something here, guys, that if we have another angle in this case, which was here, which is t, let's say this angle here is equals to t, and then with this t here, you can see that we are now applying another rule, which is the first rule that we did here. Remember the first rule that we did, that angles, adjacent angles of a straight line is equals to 180 degrees. So in this case, this angle and that angle, in this case, it's like this one is an external angle. If we just extend this and make it like that, this angle now is now an external angle of this triangle. So it's the same as the other side, that this two, where this angle is equals to the sum of these 2 angles there. All right, I hope you guys understand that. Then also in this case here, we can see that if we add another point here, let's say this is angle y there, that means that when we sum these 2 here, they must always give us a sum of 180 degrees because they are on a straight line and they are adjacent to each other. So you must always know that. So this geometry applies to a lot of things. Like for this one, for this case here, example, if we just consider the straight line here only, that tells us that this angle of x and the angle of y, when we add these 2, they must always give us a sum of 180 degrees. As you can see that these 2, if they're straight line, if we only consider this line, which is a straight line, then the angle of x plus the angle of y, they must give us a sum of 180 degrees. So you can see that with geometry, you can always apply a lot of things within the same triangle. All right, and the same with this one here, guys, that if we just extend here and make this a triangle here, so this makes the x there to be an external angle of a triangle. So you can always just manipulate around the question, because the question, it won't come like this. You have to apply most of these rules just to answer one question in geometry. So that's why you have to familiarize yourself with this and know them thoroughly well. Then guys, please don't forget to subscribe to Maths XYZ on YouTube so that you can continue to get notification when we upload videos. Alright guys, thank you.